Hello, everyone. I hope that you are going to enjoy this Sleep Science Friday post. Today, I'm going to talk with Dr. Calvin Minor. We are going to talk about climate change and sleep in humans. Dr. Calvin Minor is a postdoctoral researcher at the Columbia University. His current research focuses on human adaptation to planetary changes and climate hazards, including the impact of global warming on sleep. He's also a member of the Lancet Countdown on Health and Climate Change Working Group. So thank you very much for joining me today. And let's start with how have you come to study the effect of climate change on sleep?
Yeah, so, this question of whether, the weather outside can actually impact how we sleep indoors is really a question that people have been asking for a long time and thinking about it not just with regards to sleep, but also with other health-related behaviors and even our mental health. So I was interested in this question because I realized early on that much of the literature looking at temperature and sleep had been conducted in very controlled laboratory environments, which was very useful for understanding that in those settings, people slept and responded to temperature changes in a specific way. We have this Goldilocks zone, this thermoneutral zone of comfort, and if it's too hot or too cold, people sleep worse. But one of the limitations of that research was that it seemed to be imposing a lot of adaptive constraints on how humans sleep. And in the real world, we are extremely adept at selecting for comfort, whether that's through changing our clothing, our bedding, our, thermostat. And we really wanted to understand whether changes and fluctuations in outside temperature, which are shifting systematically globally due to human-caused climate change, had any implications for how people sleep. Now, one of the motivations here, too, is that nighttime warming is proceeding at a faster rate than daytime warming across most regions globally. And at the same time, another anthropogenic change is also changing the nighttime temperature environment, and that is urbanization. More and more people are living in urban environments that absorb energy during the day and release that as sensible heat at night. And so this question of whether temperature impacts sleep was a really interesting one that we wanted to look into.
So could you tell me how does, in general, the exposure to higher temperature, especially during the nighttime, affect sleep physiology, maybe even dreams?
Yeah, I would be very interested in the dream question. There's certainly some research that's shown again that high ambient temperatures degrade REM sleep as well. The work that I have done has predominantly focused on total sleep time, and what we've seen again in the real world through a global scale natural experiment is that on randomly timed unseasonably warm nights, people sleep less than their normal baseline. And what's really powerful about this is that this is plausibly causal evidence because we're leveraging the randomness of the climate system to identify the effects of these unseasonably hot nights on within individual changes in sleep. What we can see is that people sleep less, sleep is delayed. It takes a longer time for people to fall asleep. And I think really interestingly, we also see that the probability of individuals having a clinically short night of sleep that's less than 7 hours, less than 6 hours, and even less than 5 hours increases on very hot nights. And we know through separate evidence that many of the same downstream adverse physical, cardiovascular, and mental health outcomes that have been shown to become more likely when you restrict sleep to those same thresholds separately increase in populations during really hot days. And so sleep may be one of these important mechanisms linking ambient temperature to downstream health.
So, since this is basically like the public health issue, what are the strategies to like mitigate the effects of of these warm nights, either at the individual level or even better at the community level?
Yeah, I'm really glad that you're bringing this question up of adaptation. How do we smooth the sort of temperature shocks and their impacts on our sleep and well-being? We actually just published this week a systematic review in the journal Sleep Medicine Reviews that looked at the prior evidence. And unfortunately, I have to say that actually, in terms of ecological studies in the real world, there's not a lot of evidence showing what works best to help people adapt. However, there are some evidence-based suggestions that we can provide here. So, for one, we observed in our global scale study that people who were residing in richer socioeconomic regions were more buffered from the effects of heat on sleep loss. And we don't know exactly why that is, but presumably it is due to adaptive differences in cooling technologies or other socioeconomic amenities that help to protect people from the effects of nighttime temperature on sleep. At the same time, we also advocate for additional research that combines field experiments, basically randomly, assigning people to have air conditioning or other cooling technologies, to study whether these adaptive amenities can help people sleep better in the real world. And so we really need to do a lot more research in that domain. However, if we think about this in terms of three different levels of the individual, the community, and really the planet, there are a number of interventions that become relevant. So at the planetary scale, the emissions decisions that are made both by individuals, but most importantly by larger, societies and firms and entire industries do have implications for actually reducing the nighttime temperature burden that future generations will be exposed to. So that is a planetary scale way that we can reduce that burden in the future and imminently. Another more local, aspect of this really is air conditioning access and the equitable provision of air conditioning. Right now, it's really a market-led approach, so people who can afford air conditioning can buy that. And that works in such a way that if the energy system is not sustainable, it actually contributes to additional global warming through greenhouse gas emissions and local warming because air conditioning units work by displacing waste heat from the privileged environment that can afford it into the surrounding neighborhood that might not be able to afford the same technology. And so air conditioning is a life-saving technology, but we need to find out through policy how we can equally provide that to especially the most vulnerable populations. In our research, we've seen that the elderly are over twice as impacted by nighttime warming compared to middle-aged and younger adults.
So regarding air conditioning being life-saving, could you tell me more about what are the limits of human body to release the heat? So when the temperature outside is much higher, we at some point will start absorb the heat, right?
That's
So
right. Yeah. Yeah. So it's true that, our core body temperature, our body works really hard to keep our core body temperature relatively at a fixed level. And if the, ambient heat around us exceeds that of our body, it becomes much more difficult for our body to displace waste heat. And that's really critical because when we go to sleep, our core body temperature drops ever so slightly. And the way that we do that is by actually vasodilating and increasing blood flow to the distal regions like feet and hands. If you were able to see in near infrared, you would actually quite literally witness your hands and feet glow at night because of this process. But that assumes that the thermal gradient between your body and the surrounding environment is favorable to release that heat. So again, if the surrounding environment exceeds your core body temperature, that becomes a real problem. And again, that's very extreme heat. But one of the challenges here is that certain built environments can actually trap heat inside. So if it's extremely hot outside and people are trapped inside, you can imagine situations in which it becomes increasingly difficult for the body to cool itself and enter into restorative sleep.
So which groups, age groups in our society will be the most affected and will be under the highest risk in this context?
Yeah, so we looked at multiple different demographic groups to see if there were any subgroup differences in how they responded to hot nights in terms of their sleep. And what we found was that the elderly were over twice as impacted. So people who were over the age of 65 were over twice as impacted compared to younger adults. Interestingly, when we looked to see where the age sensitivity emerged, it really did seem that actually between the ages of like 50 to 60, you start to see this increased sensitivity to nighttime temperature in terms of sleep loss, but it continues to develop. So that sensitivity only grows as we age. And on top of that, we also found that females were 25% more impacted per degree of warming compared to males across the life course. We don't know exactly why that is. It may be due to body morphological differences, difference in subcutaneous fat content that could provide or act as an insulator, making it maybe more difficult to, shed some of that heat. And it could be due to behavioral and environmental differences in occupational exposures to temperature during the day. So there's really a lot of interesting questions that we need to actually look into to figure out the mechanisms that are explaining these differences. But for right now, we see it the elderly, females, and very importantly, people living in lower middle income countries were over 3 times as impacted per degree of warming in their nighttime temperature sleep loss. And that again suggests potential unequal access to cooling technologies. I will finally say that we also looked at the disparity across climate zones, and we were really surprised that people who were already living in some of the hottest climates on the planet were actually disproportionately more impacted, not less impacted, suggesting limited long-term adaptation, even in places that are familiar to high ambient heat.
Okay, so looking at this topic from a bit different perspective, also considering the psychological impact of climate change, how might anxiety and stress related to environmental concerns influence sleep quality and mental health?
Yeah, that's a really good question. So most of the research that I have done has really been focusing on the channel that is, direct from temperature to sleep. But it's also true that as the climate changes, there may be insidious indirect impacts, both through the stressors that climate change exacerbates, and also through the information that we become exposed to or come into contact with about climate change that may be taking place in a completely different part of the world, but that anxiety can build up. I've written an article actually about ecological anxiety and climate anxiety as well, and ecological grief. And I do think that this is a really important area that right now we don't have a lot of clear insight about, but nationally representative surveys have found that many young adults report having difficulty sleeping due to concern about climate change and associated anxieties. And so I think we need to better understand what that burden is. And also, very importantly, we have to try to figure out ways to help people to sleep well because they will need those cognitive resources to adapt and also to function in daily life, and those are both really critical components of society and the adaptation challenge that we are facing in the future.
Okay, so what are the questions that you think need to be addressed in the future, but like the most urgent questions in context of our conversation?
Yeah, so in our just published systematic review on the topic, we actually identify a few priority research areas, and I'm happy to just kind of run through them. For one, we found that actually people who were residing in the tropics, there was very little evidence and few studies that had been done in the tropics about this relationship. And that's really important because about 40% of the world's population reside in those regions, which are some of the warmest in the world. And it's really hard to escape heat when you're living in the tropics. Now, we also found that many vulnerable groups were underrepresented in the literature. So we found, for instance, that there were very few studies with children and even fewer studies with infants. And I think that's really important, especially because children and infants today, during their lifespan, will be exposed to more severe climate stressors and also already are at a very vulnerable life stage when they're coming into contact with some of these increasingly severe heat waves and other temperature-related events. I also think we need to better understand what the best, methods are to adapt and to help people who are living, especially in vulnerable regions, to do so. And that may involve other cooling technologies that don't require the same sort of energy demands and that aren't as expensive as air conditioning. So that's really an important avenue of research. And finally, we're finding these impacts even in some of the richest parts of the world. And so we need to better understand why, even in places where people do have air conditioning, we're seeing sleep loss on really hot nights. There may be other channels that are linking these ambient temperatures together with these individual changes in sleep, and we need to better understand and resolve those.
Okay, so can I ask you, what are you going to explore in your next studies? What is your plan?
Yeah, I think, there's just so much work to do still. One of the big priorities for me, and I'm really interested in, working with other organizations and researchers to do this, is to better fill in the gaps of, again, much of sub-Saharan Africa, large parts of the Middle East, and large parts of South America, where we don't really have any monitoring or assessments of what the sensitivity of sleep to temperature, ambient temperature is in those parts of the world. I think we need to look very carefully also at better understanding the sleep susceptibility to temperature in captive populations, so incarcerated populations. Many prisons don't have access to air conditioning, and that is potentially a hidden burden. We know that the mortality rate due to heat in prisons, say in the southern part of the US, is over twice the background rate for the rest of the population. So I think that's a really interesting question as to whether sleep might be playing a role in even mortality that we see on really hot days. And we need to better understand what that burden is for other populations that have limited adaptive capacity, including homeless populations. And so that's an area that I'm really interested in.
Okay, thank you very, very much. I could ask you many, many more questions. But yeah, for now, I would like to say thank you. And we are going to put some links to your publications and to your Twitter account so others can follow your work. So thank you very much once again.
Yeah, thanks so much for having me on. It was a pleasure to talk, and please feel free, anyone, to reach out via email. I'm happy to chat further.